Hello again. My name is Thomas SAKS. I'm from University of Freiburg and working in a project Cicada. And first of all, I would like to express my gratitude for giving this opportunity to talk about glaciers. And kind of what I will give today is kind of a summary of what we know today about glaciers in Central Asia, how they melt and where we are basically, and maybe some words of what we can expect. So first of all, why the glaciers are important? There are many reasons, but I would say at least for Central Asia, first of all, it is runoff, because glacier runoff in summer dry season is very important. So water resources. Secondly, it's important for the disaster risks or natural risks, for example, glacial lakes and their future formation due to climate change. And third, it's also climate, it's also the sea level change, because glaciers also contribute to that. And if we take a bit closer look to, first of all, how high mountain Asia, and here in these graphs you can see the share of glacial meltwater in the total runoff of the rivers. And so you can see that in Central Asia, glaciers contribute quite a lot to the runoff in summer season, and some of the rivers, like Amu Darya, for example, the total 50% of the total runoff, or even more, is glacier water. So glacier water is very important, and therefore we have to know about glaciers, how they are melting, and how fast they're going to disappear, at least some of them. So now I will tell some words how we do it, how we measure glaciers, and what are the basic results for this region. So first of all, we do in situ measurements as glaciologists on glaciers. We measure how much they melt, how much the snow is accumulated, and from that we get the mass balance, and mass balance is the measure of the glacier, if it's gaining mass or losing mass. That's what we want to know. Secondly, we can use remote sensing data to conduct regional studies and see how regionally glaciers are melting. And thirdly, we use, all the scientific community also is using numerical modeling, so to be able to say how the glaciers will change in the future. And from that, apart from the information about glaciers, we also can say something about the future runoff changes. Like here's one little graph beneath where you can see how when we can forecast when, for example, a particular glacier will have the peak flow. So saying what year, if we have the sufficient climatic projections. And secondly, we can use this information for estimating natural risks from glacial lakes, so glacial lake outburst floods. Yeah, so for process modeling. So these are the results which we have now, meaning the scientific community, for the in situ measurements for the Central Asia. So in total we have currently 7 glaciers on which mass balance has been measured and is measured again, is continued now. So first of all, you can see that the glacier mass balance measurements started in late 50s, namely on Lake Taющие, just above Almaty. And they were continued until 90s, basically, and except the Taющие glacier, all the other glacier monitoring was stopped, basically because of the collapse of the Soviet Union and changes of political systems and so on. And here on the right side of the graph you can see that on number of glaciers we have resumed the monitoring, and it's also partly thanks to the Cicada and Katkos projects, which are working here. And from these lines, what you can see basically is the cumulative mass balance change of glaciers over time, over the years on the lower graph, And you can see that from early 70s, the mass balance is more or less constantly negative. So glaciers are melting, and they are melting for at least 40 years, more or less continuously. Secondly, after direct measurements on the glacier, we can use modeling tools. For example, like in here, we use the surface mass balance model to reconstruct the mass balance for the years where there is no data, no monitoring data. So we can use this data for future studies. Then one of the new methods developed, especially here in Central Asia, is the usage of the snow line observations on the glaciers. On 4 of the glaciers in Central Asia, we have installed the cameras which monitor daily the snow line position on the glacier. And from this information, we are basically able also to calculate mass balance for particular glaciers. And secondly, by combining direct measurements for validation, surface mass balance modeling, and snow line observations, we can derive mass balance also regionally. Yeah? So it's also a good tool to say how is the particulate mountain range doing, or the glaciers in particulate mountain range, how they are melting. And the last but not least, as I said before, we need all of these different kinds of studies to be able to say something about glaciers. Is the regional studies on remote sensing, which has been also recently published by Brun et al., where they used geodetic mass balance to estimate the regional mass balance for Tian Shan, Pamir, and so on. And also the bit earlier study by Farinotti, also modeling study based on multiple satellite data, not the but remote sensing data, where they also were able to reconstruct the regional mass balance for Tian Shan mountain range for the last 50 years and say something also about the future. So to sum it up, this is the picture we have now for Central Asia. So first for, let's look at the different glaciers, and then I will try to sum it up in kind of normal language. I will try at least. So for 3 glaciers named here, Abromov, Golubin, and 354, for all of them we have the currently negative mass balance, so the glaciers are melting, and you can see that there's still variability. But it's quite, especially for Golubin and 354, it's quite, all of the different methods derive more or less the same result. And also regionally, if we look, then most of the studies suggest that currently all of the glaciers regionally are melting. So in Pamir and in Tian Shan, and mostly, yes, in Pamir, Pamirala and Tian Shan, the glaciers are melting. But you can see that there's still quite a bit of variability. So we know that they're melting, but we don't know exactly how much. And why is that? Is my last part of the presentation is more to raise awareness about glaciers, I guess. So there's a very simple comparison. If we look at area of Tian Shan and Pamir, glacier area in the Tian Shan Mountains and in Pamir, which is around 24,000, and we have 7 glaciers which are monitored. And for example, in the European Alps, we have just around 2,000 square kilometers of glaciers, which are glaciated, but we have 64 glaciers which are being monitored. So from this, I'm saying that glaciers are definitely not enough. So currently in Central Asia, the glaciers which are monitored are these. It's in Uzbekistan, it's 1 glacier. There are 4 glaciers in Kyrgyzstan, 6 glaciers. 1 glacier in Kazakhstan, and we hope that this year we will start monitoring at least 1, and then next year also at least 2 glaciers in Tajikistan, because Pamir is the area which is very huge and we have very little data about glaciers there. And why do we need it? Why do we need to monitor glaciers? Maybe also to the wider community, not for glaciologists. So first, as I mentioned, we can use this information to model, to say something about runoff in rivers, and we can also say something how it will change in the future. For example, here is one study presented for Sirdarya, how and when the Sirdarya will reach the peak flow. In this study, it's mid of this century, and then it will decline. So this is something which can be used already for adaptation. And secondly, the glaciers are important for the disaster risks, namely glacial lakes. So also, the more we know about the glaciers, the more we can say how they will change, the more we can predict, for example, where the new lakes will form. Yep. Okay. So to sum it up, I hope I'm still on time. In conclusion, high-quality cryosphere data is an indispensable prerequisite to any sound water and hazard-related studies in high mountains. They have to be ensured and internationally shared in the regional and worldwide data centers. Secondly, regional cooperation on WRM and DRM, or disaster risk management, and awareness has to be increased based on the national efforts. And this is also what our project is currently concentrating mostly, that after us, the glacial monitoring is continued by national partners. And thirdly, education or capacity building by introducing up-to-date student courses on bachelor and master's levels, as well as PhDs, by summer schools and by specialist field training have to be conducted. And last, collected high-quality cryosphere data has to be used with modern analyzing tools for improving WRM and DRM. So also modern tools like modeling software and such should be more and more introduced into the responsible agencies such as Hydromet and other research institutes which are responsible for water resources management and disaster risks. Thank you very much.